All right, at the end of our last video, we had built a static simulation model of these average healthcare claims going through, costing the company about $36 million. Now what we want to do is we want to go through and add some more realistic behavior to this model. We're going to do that using random numbers, and we'll go into this. You'll see I have this in a new spreadsheet here, or a new workbook. I still have my average claim per employee in all this here, my number of employees. But now our assumptions have changed a little bit. So I have a max increase of the number of employees of 0.03, a max decrease of 0.03, a max increase of 0.07, following a uniform distribution. Okay, so we will look at that. Our monthly increase is 0.01 with a standard deviation of 3. Okay, and that comes from a normal distribution. So we have a couple things to look at here and what we're going to do. So let's take a look at how we model this. First thing is we want to look at our number of employees. So this is going to start with our previous number of employees. And we said this is a uniform distribution right here. So we are going to go to our RNG uniform function. Now if we go over to our Explorer, you'll see that there is a min and a max. We see the max decrease is 0.03. The max increase is 0.07. Okay. So what we want to look at is 1 minus the maximum decrease up to 1 plus the maximum increase. Well, why are we doing this? Well, we just want to multiply this one time. Now, this should be a multiplication, not an addition right there. I mistyped. Okay, so we want to look at our previous number and we want to multiply that by some amount. So you'll see if I hit enter here, if I start hitting F9 a few times, this is going to dance around. So we're going to go move anywhere between down by 3% to up by 7%. Okay? This is the same. If you were looking at it the way we modeled the previous one, you could say plus D2 times that same amount. But it does the same. Oop, I made a mistake there. If I did D2 and got rid of the ones, same formula, right? That's the equivalent. Because in this case, I'm saying look at my original number and add some percentage that ranges between 0.03 and 0.7. So this would actually be minus 0.03 and 0.7. And you'll see if we dance around here, we'll go up and down in various combinations. So, but the way that this looks much, much cleaner is to say if it is D2 times 1 plus, don't even have to do that, times the uniform 1 minus to 1 plus. I can hit enter, correct my formula, thank you. And now, just like before, you will see we don't want to look at that. We want to look at our previous period. Okay, so we may go up and down all over the place. You'll see, but now we have a varying number. Generally, we trend up. Why do we trend up? Because our max increase is significantly larger than our max decrease, so we're always trending upwards, even if we lose people in there over a few months. So you'll see 19, 20, down to 19, down again, right? So we go back and forth quite a bit here, and it ranges. We get a really, really wide variety. Okay, so now we have our employee contribution. This is our number of employees times our average contributed per employee. That's the same now, right? That's not going to change. Oh, again, I keep forgetting to lock these values. Put that down, hit F9, the numbers are going to dance around. You'll see there's quite a bit of variation in there. Okay? We also have our average claim per employee. Now this formula is going to be a little bit different. We are going to look at our RNG normal function. You'll see if I look at the RNG normal, I have a mean and a standard deviation. Okay? So if I do my RNG normal function, what I'm going to put in here is I'm going to put in my average claim per employee. I'm going to lock that. I'm going to multiply that by 1 plus my mean monthly increase, this 0.01. Okay, so RNG normal with this, and I am going to raise this to a power of the number of months. And then for my standard deviation, I will put in there 3. Okay. Now you may be asking, what does this formula do? Well, first off, let's drag it down here and we'll see how this works out. If I hit F9, you'll see it goes up randomly. It's slowly going up. It's slowly increasing. It looks like it's very correct. Well, if you want to look at this formula, what it's saying is, well, look at that average claim per employee. This is going to follow a normal distribution. But my average claim, my mean of my claim, right, is going to increase by 0.01. So that's my base amount times 1.01%, right? That will give me a full amount. And I'm just looking at as many times as there are the month that I'm in. So in month 1, I say, oh, it's my average claim times 1 plus 0.01 raised to the 1 power, right? So that just gives us 1. In the second month, I do it twice. I have 2 multiplications because I'm in the second month and it would have increased with a mean of 0.01 twice. So on and so forth. This formula is also in your book, so you can look at it more deeply. We look at our total claims, which goes to our number of employees times our average claim per employee. Same formula as we used before. The company cost is the total claims minus the employee contribution. Take that, drag it down, sum it up. And we now have a working simulation model. Okay. Now the problem here is, look at that variation: 35 million, 40 million, 35 million, 37 million, 32 million, 33 million, 44 million. You can't very well walk into your boss and say, hey, it's going to end up somewhere between 33 and 44 million, something like that. So we have to figure out a way to look at a bunch of models and see how things work out. So what we want to do is we want to run some trials. We're going to put this down here. I'm going to start with 1. I am going to use this little Excel trick. I'm going to say fill a series. I want to fill down a column with linear growth. We'll stop value. We'll stop at 100. So you see this actually fills in the values 100. Now I'm going to use a little trick here. I'm going to highlight the whole row at 3. I'm going to hit Shift. While I'm holding in Shift, I'm going to press and let go of the End key and then press down. That's going to select all the way down to the final trial. And then I'm going to press up a couple times, still while I'm holding the Shift key. Now I will release that. I will go over to my row number. I will right click and I will say hide. That's going to allow me to hide a bunch of rows. So again, I go in there. If you ever want to see these, you can do unhide. So again, I'll go in here. I'll go to the third trial. Press and hold down Shift. Press and let go of End. Press and let go. Oh, there, I didn't select the columns though, or the entire row, so I need to go back up. Select the entire row. Hold down Shift. Press and let go of End. Press and let go of Down. Press up a couple times. Right click on the numbers and say hide. Right. So what I want to do is I want to run 100 trials of this simulation and see what it looks like every single time. The way I do that is I put a marker in here to my total cost. Okay? So that tells me that I'm going to be running these trials at a total cost. I select the whole thing. I go to data. I go to what if analysis, and I pick a data table. Now I have row input cells and I have column input cells. In this place, I want to pick my column input cell and just pick a blank value and click OK. Hey, what that does, I'm not replacing any values. I just want to do this. And if you see, I hit F9. Now this is going to take a second this time because I've done 100. You'll see all these values suddenly changed. What that's doing is it's looking at the value here, which references my total cost. And whatever gets calculated here, it's recalculating it once for every trial. That gives me a wide variety of results. And now I can take a look here and I can look at 2 things. First is my mean, right? I have my average. I'm going to take my average value. I'm also going to look at my standard deviation. I'm going to use standard deviation P and look at that. Okay, so make these both in here, bring these up, make them $signs. So I am looking at about $36 million plus or minus $2.2 million. You see, even if I press F9 again, it'll take a second to run and things will jump. But we're staying right around the same value. This is really, really important thing. because it's showing us what we actually have here and what we're able to do. Okay? So the thing that we actually want to do here is we want to build what's called a confidence interval. When building the confidence interval, we generally want to build a confidence interval that is what we call a 95% confidence interval. That doesn't mean we are 95% certain that our answer is correct. It means that 95% of the time, statistically speaking, the solution, the result will fall within these bounds. So the question becomes, how do we calculate this? Well, we want to look at our mean and our standard deviation. These are absolute requirements that we definitely need to have. We want to look at our sample size, which I'm going to go ahead and highlight here. Now, to build a 95% confidence interval, right? So we want to do the upper 95% CI and the lower 95% CI. We want to look at a couple things. To do the lower version, we look at our mean. For the lower version, we look at the mean minus the value 1.96, and we multiply that by our standard deviation divided by the square root of the number of samples, which is 100. And we can actually lock this in here. None of these are going to move at all. That'll give us the lower limit on our confidence interval. And then I can change it up here just to a plus. And you'll see if I hit F9, I now have a lower and upper 95% confidence interval. See, I can say that 95% of the time my result should fall between 35,590,000 and 36,405,000. Now you may be wondering where that 1.96 value came from. Now that definitely changes depending on what type of confidence interval we want. For a 95% confidence interval, we typically want to use a value of 1.96. That's how the calculations work out. There are ways to calculate this for other distributions, for other confidence intervals, but I will leave that to you as you can find it in your book. So long story short here, we have built a model, and for the first time, we have incorporated truly random behavior into our model. This lets us run multiple simulations, right? We've done all the random stuff, and then down here we've run multiple trials of the simulations in order to get good results, to get a wide sample, and to figure out what is actually going on so that we can report those results in a confident way. Now, I will tell you, if I were doing this for a business in practice, I would probably run this more like 500 to 1,000 times just to get a little more confident. The more trials you have, the more confident you will generally become. All right, with that, our first example is done, this healthcare example, and you should be good to go.